Thanks, Lizzie. Changing tact a little bit to, I guess, a more practical strategy around what we can do in some of the scenarios. So we've got Stephen Simpfendorfer from New South Wales DPI is our next presenter. So Stephen's based in Tamworth, one of the most practical researchers in our space, really engaged with industry, engaged with agronomists through Twitter. He's happy to get on the phone and talk about what's happening. We send samples, but also really interested in feedback as to what's happening at our end, not just from a research perspective. So I welcome Stephen to the stage this afternoon, to talk about fungicide resistance in cereal pathogens, but probably also a bit of an update on how the season's gone in his eyes. So welcome, Stephen.
Thank you. So now for something different. So everyone worries about the afternoon slot. I apologise in advance if you haven't heard me talk. I tend to get a bit excited as I go on. Hopefully I don't use any colourful language. Apologies in advance if I do. But yeah, you just need to hear this. What do everyone think of Rob Park's talk? Who's shit scared? Because the whole argument about fungicide resistance has been, oh, but it doesn't happen in rust. We can keep spraying, it doesn't happen in rust. It happens in rust, guys. Okay, fungicides. This is just some number out of crop life. We use a lot of it and we get a good return on investment. So $14 in 11-12 for every dollar spent on fungicides. 17, 215, 16. This year, I think we used a lot more than we probably ever have historically on the East Coast. Okay, and it'll be an attractive return on investment. Okay, and if you want to get a much better return on investment, grow very susceptible varieties. Because you'll see pictures on Twitter and everywhere of missed strips or the plane was late and how much it's cost you with your stripe rust in particular. Okay, not where we want to be operating. Okay, no debate. Let's just move on. Fungicides work. Okay, when it comes to stripe rust, there's no need for us to waste our time on that. They are very effective for now. Other diseases, Brad talked about septoria, wheat powdery mildew. We're running into issues with some of those cheaper triazoles in particular, reduce sensitivity. Okay, I think we can add leaf rust in barley and wheat to that now. When that stuff is in a glasshouse plants and you're spraying it with, 25 times the rate and you're still getting pustules, show's over. I'm convinced. Head blight, we're not worried about issues, but the point I want to raise there, we've got a lot of issues with people being spraying for head blight this year. We've got low levels. It's a coverage issue. You've got to think about the targets you're hitting as well. When it comes to head blight, it's very different. Same with some of the wheat powdery mildew. So a lot of instances where I sprayed it by plane, I've got no wheat powdery mildew in my canopy, but I've got a heap on my heads. You're trying to hit a different target. You're trying to hit an upright target, not a horizontal target, which is your leaves. So we need to think about how we're doing this if we're going to improve things. And this is the situation we're in. And you hear this all the time. It's cheap insurance. You know, and you can't argue with that. So whenever you see something go wrong in the paddock, the tendency is, well, which drum am I going to use? You know? Where am I going to go? And yeah, that's something we've really got to challenge. And here's an example, okay? Low levels of Fusarium head blight. You get these bleaching of spikelets in the head. The fungus infects during flowering, and yeah, it kills those off. Since the end of September, 169 samples have come into our diagnostic surveillance where we confirm we've got Fusarium head blight. Okay, so it's widespread. And where it's coming from, and we're going to confirm this, but where we're pretty sure it's coming from, because we've seen it before in wet years, 210, 216. Basal infections with Fusarium crown knot, I can yell. You get that basal browning. In a really wet year, you get spore masses produced around the lower node. They splash up through the leaves, up into the heads at flowering. They give you low levels of Fusarium head blight. Okay? We know we've got big levels. And through our random crop disease surveys, we can put out maps like this, where the more red the colour is, the higher quantitative level of the pathogen using DNA that's in the base of those plants. And you can see how those numbers are going up as we're getting more cereal back in the system after a run of droughts. Quite high in a lot of levels, and that's where we're having our head blight problems. Okay, so you warn about it. You tell people this is the link, this is what's going on. What's the first question you get when you tell someone they got head blight? What should have we sprayed? Okay? Sorry. The problem's there, it's sitting in the base, but everyone just wants to look at the heads. My thing is, look at the base of the plants. It's staring you in the face. You've got to just accept it, okay? We can't just ignore this stuff. We've all got this beautiful, how to prevent, apply fewer fungicides. And it starts down the bottom, and I don't think we emphasise this a lot. We've given up the fight on some of our resistance stuff. Who remembers minimum disease standards? Okay? And we used to be passionate about it. H45, when we had that stripe rust, we were really aggressive. We cannot sustainably keep very susceptible varieties. Where's that argument now? Is it just all too hard? It's all private breeding companies. We can't do it. Let the market decide. You know? Anyway. Growers. Put your hand up to 5% of growers in the room. Okay? You people have got the control. You dictate what varieties actually get released by breeding companies. If you don't like it, don't grow it. You can... Yeah, well, you've got a couple left, but you've got to show the intent. The problem is you've got to show the intent to change over time, and we'll go through some of this. We all know that's the base to it. But when you look at some of the stuff, and like I've taken names off and I shouldn't be influenced so much by social media, but you see stuff, you know, Rockstar, susceptible to stripe rust, big problems, copped to flogging by industry. At the back end, really good genetic potential. We can use 2-3 cheap fungicides and we're not the problem. You know, certainly you look down, and this is from the southern area, Victoria, basically saying, yeah, fungicides are doing the heavy lifting, but the acknowledgement's because we're growing very susceptible varieties. And it's hard to argue this one too. You can actually use quite cheap fungicides, it'll pay for it. So what say? Even at top range, 20 bucks a spray, 5 sprays in a year, 100 bucks, you'll keep everything out, pretty much. How much grain's that you got to get at 350 bucks? 0.2 something. Not a lot of grain, and this is what we fight against, but I think we need to look at the repercussions. And even when you put stuff up, this was Grains Arana with a trial where they didn't put any fungicides on, trying to point out what the genetics can do. And you can see stuff here that's just totally stripped out, nothing left with stripe rust, others that are kept some green leaf area. Okay, trying to make the point that there is stuff there. I know we can't grow all these rowan, but we need to push people towards this is where we need to go as an industry. But what do you get to that? You get the realisation that on the ground, it's all about yield. Okay? So yes, some of these varieties mightn't need anywhere near the protection for stripe rust, but the perception is they're costing you 15% yield, so that's a fair few sprays you can actually put on those crops. Okay, so that's what we're up against. So in some ways, that's why we end up in situations like this. So some of our dominant varieties, except as one of our big ones, that's its resistance range. So it's not just stripe rust we're targeting, it's usually a range of other pathogens as well. And that's what we've seen is we've probably had some of our bigger septoria issues in varieties that weren't as bad for stripe rust, didn't get as many sprays, but then fell over at the end. But yeah, how do you manage something like that? So if you're spraying it for stripe rust continuously, you're off target selection for these other pathogens as well, which we'll go into. But I think we need to really take Rob's advice and warning on hand and accept it. We're probably selecting for resistance in our stripe rust as well. Hey, we're world leaders. Fran told us we're world leaders. Highest frequency of fungicide resistance in Australia. You beauty. Let's get stripe rust on the list too. Okay, so we're back to here, okay? So there's an element, and like the problem is, you're preaching to the converted here. You wouldn't be here if you didn't know this is an industry issue and you're actually interested in it. How do we get to the others and bring them on board? Because picking a blue is not going to get us there. Okay, crop rotation, manage the green bridge for rust, and you've got these stubble managers. All important, Brad went into this. Sorry, Brad, I'm not really on board with the delay sowing either. Certainly with crown rot, we know in its window, so late you'll double your yield losses from crown rot. So it's an idea, but it's not one that fits practically. And then we've got all our stuff around, you know, fungicides, rotate, use mixes, stay within label rates. At the moment, it's largely an ideology out there in industry. It's not practically what's happening on the ground. Okay, number of reasons. The stuff's cheap. Okay, so you'll tend to go on price, go the cheaper stuff. Availability too. Sometimes it's what you can get your hands on. There's not there on hand that you can just switch around. And also, I don't think it's forefront of mind at the moment is to say, well, I'm going to actually spend, 3 times or 4 times as much just so I don't get resistance maybe down the track. Not how it works. If it's effective, they'll just keep using it. The other thing too is there's a lot of spraying goes on for things that aren't even diseases. So this is Brad and myself, diagnostic service we offer with a joint project with GRDC, New South Wales DPI, bilateral, we both co-fund it. Big year, 1,148. Doesn't sound that impressive. And that's the coverage that we're getting, whether it's an inquiry, people send us photos, give them advice back, and then diagnostic samples. 35% stripe rust, and you can see the others. So yeah, big stripe rust year, and that fusarium head blight number's going up by the day as we see stuff. The point I want to make here, but 14% of those are actually not disease at all. So that's 159 crops sent to us where people thought they had a disease, they needed to apply a fungicide, there was nothing to do with the disease at all. Okay, so my thing is, always be sceptical. I come from further north, based in Tamworth, tend to service sort of Dubbo up. Lancer for us is a pretty good variety. A lot of Lancer crops sprayed for stripe rust this year. For this situation here, where you've got an individual plant with a lot of stripe rust in it, surrounding plants are fine. Seed contamination with a more susceptible variety. Low level 1%, some of it's catapult, some of it's a variety ball ag, and it gets sprayed because they look at that individual plant and go, Lancer's breaking down, I've got to spray it or it's all going to be orange. Okay, that's just telling me you've got very poor seed hygiene. Melanism, we saw this in varieties that carry the SR2 gene, you get that darkening of glooms. Whoops. Thanks, buddy. I won't advance my thing now. I haven't got that many hands, have I? Darkening glooms. So this is just an overexpression of a pigment, melanin, high humidity and UV. Before we pulled this up on Twitter, there was crops in southern Queensland getting sprayed because they thought it was early head blight infections. Okay, waste of fungicide. And we see this leaf tipping as well. So yeah, there's a lot of things. Correct diagnosis. So having that phone a friend, send us pictures, I think can really help. So, talking fungicide resistance in 2022, this was a massive year for cereal diseases. And trying to talk fungicide resistance in amongst that, this is how I think Brad and I felt a lot of the time. Okay, we need a few more of you to join us on the beach, okay? We're going to hold this back. Trust me, all you're going to do is get wet. Okay. One of the big challenges we've got is that bottom rung again, okay? The pyramid all starts with that strong foundation. We've got to get back onto this. So when it comes to stripe rust, the challenge is out there. Can we really grow those susceptible varieties sustainably? The point I make here is you actually got a shorter cycle time. So the more susceptible it is to, the quicker the fungus is cycling. So we say it's got a 10 to 14 day cycle time. 10 days in the more susceptible it is, and that expands out towards 14 days as you go up in resistance level. And anyone who had delays in spray times this year sees how much difference a 4 days could make, okay? So you're really pushing it if you're doing that. The other thing, if we've got a lot of susceptibles, we're putting pressure on our more resistant varieties, okay? Lancer's been great for us. It's been a stand-up for us in the north. I don't care if you don't grow down south, I'm over it, okay? But if we want to break Lancer, why don't we put really susceptible off-types in our Lancer, let them get full of rust and challenge the Lancer plants. Makes good sense. You can't get away from rust, okay? And powdery mildew is the same. They're social diseases. These things have got long distance wind dispersal. So what you do affects your neighbours, affects people in the Nest District. And yes, Rob showed, blows across from west across to the east, okay? We eventually inoculate New Zealand, so all good. The other thing we've always talked about, so this is, and you'll hear Rob and Cole Williams in the day, the more spores you got, it's just a numbers game. The more chances of getting mutation that's going to take out a resistance gene, but also that may have reduced sensitivity to fungicide. So we just can't keep those susceptibles because they produce so many more spores. The other thing we tend to forget, it's all about that green bridge. So as Rob said, biotroph needs that living plant to survive over summer. But the more susceptible that variety is, the bigger green bridge risk it is. So everyone says, I can manage Vixen and Rockstar, I just spray it and I don't get rust in it. What are you doing with it over that fallow period too? Because you've got to be on top of all of them because it doesn't take many and that's where it starts. This changed a bit because of Rob's talk, but I didn't change the slide. Over-reliance on fungicides is giving us off-target selection. So we've got evidence that that's what we think is happening with wheat powdery mildew, but I think we're going to run the risk of losing it for stripe rust as well. So that argument that we don't get stripe rust, resistance to fungicides or reduced sensitivity in rust, I think is gone after Rob's stuff. The other thing is you've just got no flexibility with in-crop timings. So the more susceptible, it's cycling at that 10 days really quick. If you're late on a spray, you've got big problems. And we saw plenty of pictures of this sent to us and things. This is around deniliquin, Vixen, very susceptible to the 239 pathotype. Plane couldn't get there, 10-day delay, that's what it looked like. So it had a 32 spray, it missed its 39, was 10 days late. Probably somewhere 40-50% yield loss for 10 days. Okay, all good till this year when we couldn't get on paddocks, couldn't get planes. When you're growing things like that, yes, you can have high yield, but you've really got a lot on the line. You're risking a lot. I said this, what happened to the minimum disease standards? I won't go over that again. And I'm going to get myself in trouble and never get funded again. But anyway, are we inadvertently sending the wrong messages with some of the stuff we're doing? NVT trials, okay? How many people got down to NVTs? I went to one that had 5 fungicide inputs. Flutriafol on starter and 4 in crops. Growers' advisors were really impressed with how clean it was compared to the Goa site where there was no fungicides. But is that what really message you want to send? The other one is, and I won't dob him in because he's in the room, little birdie told me, crop competition in an area out this way. Vixen, very susceptible, 3 hits of epoxyconazole. And that wins a crop competition. Anyone got issues with that? Best practice, all good? Okay. So bottom line is fungicide resistance is not being taken seriously and isn't part of the whole judging process of actually best practice. Okay, and I think we need to come as an industry a bit of a standard, whether it be NVT trials or whatever, what's the actual accepted maximum input? So if it ends up 3 fungicides, that's what the MVTs get, and if there's something in there that can't cope and has big yield loss after 3, let it have shit yield, because what you're doing is just promoting this over-reliance on fungicides. 5 minutes. Okay. My challenge, I think, is this really what we're doing at the moment with fungicide resistance. We know there's issues, they're jumping off, we seem to be happy sitting down the bottom there. Okay, I think we've got to change that. Weak powdery mildew, I'll rip through examples. We saw this problem, we're able to link up with Fran's group and get some work done. And this is where I think science and generating data is really important, not that it's probably had impact. We can see the gateway mutation, same data presented, high frequency, and we've got a number there that also got the strobilurin resistance at high frequency as well. We know the issues coming from very susceptible varieties, so largely susceptible Vixen, very susceptible to weak powdery mildew, high irrigation or high production zones, massive inputs of N, powdery mildew loves it. Bottom line is growers are going to keep doing it. It's highly profitable. They'll keep doing it until it's no longer economical. Till they get the point they've got that much resistance to powdery mildew, they're not working and it's actually impacted on yield and their bottom line. That's just how it works. The question they asked, so I did meet up with some South Australian agronomists on a Zoom call. All they want to know about managing powdery mildew, which fungicide? Don't tell me I can't grow these varieties. Okay, we've got to change the attitudes. Example down the bottom here, because this is my patch, Weevil, so I'm a bit passionate about protecting them. This guy had a 51% frequency of strobilurin resistance in his weak powdery mildew. Grower has never used a strobilurin on that farm ever. Never used one. They're like, how? And he's like, how the hell did I get it? The problem is with some of these practices, when you've got long wind dispersal, you're making a decision for the whole industry. So you're making the profit growing high yielding, putting the inputs, creating resistance issues, and now everyone's got the problem but may not have shared in the profit. So, I'm going to waste my time. Heard also one of the breeding companies that probably has a stronger focus on resistance is now going, why are we bothering? Everyone just wants high yield. Why are we putting stuff out there that's a bit off on yield but it's got better resistance? We should just do the same. We go there, we are in big trouble. But an industry divide, it's a pick and a blue. I agree with old mate, it'd be really attractive, let's just blame South Australia, okay? Probably preferable if it's the Queenslanders being from New South Wales, it'd be better to blame them. But in some ways, it's just like what we see in the US, it just distracts from actually addressing the underlying issue. We put our focus in energy, no, it's your fault, your fault. I said to Rob with his stuff, there'll be elements there will just go, with rust resistance, leaf rust resistance, it's actually the exotics coming in. It's a biosecurity issue, it's not us doing anything wrong. Okay, not the message. We need better understanding of our fungicides. This is some work done on curative activity. Rob was involved with him, with Nick Park. Just quickly showing with rust, once you get to that 7 days, you're still getting active pustules and scarring, so necrosis. And variety, some of the products do differ. I think we need a better understanding of that, so actually put information out there as to what we should be using, okay? So there's science is the next thing. We need better data on efficacy, mixes versus singles, not just for resistance management, what's it actually doing? How much longer protection? How much better is it? Particularly when we're attacking mixed pathogens, we're trying to control. A lot of confusion around rate, activity spectrum, okay? You'll see stuff out of the US where they've just got a simple system for the different cereal diseases. Is this particular active or this particular product poor, good, excellent? Just a simple system. We don't have anything. So when you're trying to spray for stripe rust and septoria, you don't know whether you've got a product that's really strong on rust but poor on septoria or the other way around. I think we need to give that guidance. It's just something that's going to help it. Otherwise, we're just going to spray and merrily keep spraying. Timing, we've learned, is critical. I think we've got to do a lot more on application technique, upfronts, granary by aerial. We see a lot of stuff with aerial, but not having things set up right, not the right water volume, means we don't do a good job, means we've got to come back in again. Nozzles and what we're angling, water volume. The other one is we see a lot of tank mixes where just aren't straight fungicide. They've got, I think the worst I ever saw was a 7-way things that had bloody herbicide, multiple nutrition things. But what's it actually doing to the efficacy of the fungicide in there? So just because it's one pass and we think it's cheap, we'll chuck fungicide in, is the fungicide really doing its job? Are we just now locked in to do another one? I think we need early warning systems as well, so there's a bit of stuff with BioScout or other wings. We need to know what's going on, particularly in that latent period. The biggest problem with all these diseases, you can't see what's going on until it's too late. So we know that proactive, protectant approach is king, but you get that opposition is like, well, I don't want it. Grower says, I don't want to do anything till I see it. By then, you're in trouble. Also, rapid diagnostics. Sorry, I'm nearly... Just keep babbling. This is how it usually works. Quickly too, Susceptible. I think the other thing too is we need to really knock on the head when we truly do have resistance issues or don't. So we saw an issue in the north with Susceptible. Frank can say the name, I can't. And seen a lot of spot form and net blotch where it was treated. What we actually put it down to was just a lack of uptake. So in our high heavy clays, we can actually get our root system into stored moisture. Our surface layer usually dries out. We're not getting dispersal of the active off the seed coat into the surrounding roots and taken up through the plant. Okay? Wouldn't it be nice to actually be able to test that was what's happening? What's actually in the plant? So with some of these spray failures, actually get pathology and chemistry, and we actually, under the bilateral, JDC and DPI funded a project on this with Mick Rose up at Lismore there, and you can. So we did it with tebuconazole. And this is looking in leaves over time, over a 30-day period, at the half label rate, twice rate, as to what that actual level in the leaf is. Okay, I think we need to give this sort of evidence to growers, advisors, to know what those fungicides are doing at a half rate or whatever. Okay. Very nearly there. The other thing we do with Brad and I is active surveillance. So random crop disease surveys. And thank you to all the agronomists in the room that helped collect samples. I should acknowledge, sorry, I'm going back in time. Fran thanked us for what we did with the wheat powdery mildew. We didn't do the heavy lifting. Agronomists did the heavy lifting and sent the samples in. We were just the enablers to get them over there. So we are very reliant on our agronomist network to get stuff done. This is what we're doing for pathogens, collecting plants, visually rating, actually cutting them up then, and we're getting quantitative PCR done for levels. That's where that crown rot map I showed you, where you could show crown rot levels are building up on the DNA. How do you actually get that done for fungicide resistance? How do we get that into just a background thing like a predictor bee or these random crop disease surveys? We can produce a fancy map like this, showing that, 219, we didn't have an issue. We've got a fungicide resistance, reduced sensitivity issue starting. Yep, southern New South Wales, the problem. It's getting worse there and it's spreading up into the north. Don't you think that'd be compelling data to put out in the industry? Try and knock it on the head. There's actually ramularia data. Barley. Okay, gene frequency, all great, but I think at a grower level it comes down to say what do I actually spray? Great to know you've got a problem, but they want to know which one to do. And I think that's where Rob's stuff, I think an image, we're all very visual. Those images of 12 times, 25 times the rate and you've still got rust, those things have got to get out there to industry to make them take it seriously. But how do we determine it rapidly? Because the problem is if you can't give a grower and agronomist a solution, they're just going to keep doing what they do. You've got to lead them along and show them the path to get there. So yeah, how do we do it rapidly? I know you guys are using LAMP in WA to do it a bit rapidly for some of the frequencies. It's actually getting out there to say, well, this product isn't going to work on your powdery, and here's the evidence why. You've got to try this. So I really see our role in the challenge here is we've got to bring compelling science to the argument. We've got to join in. We're not going to be able to turn those lemmings off the cliff. The other one too, just because it's not popular doesn't mean it's actually wrong. We confront that all the time. So very good pathologist who's retired in South Australia, he was the advocate for minimum disease standards, you can't grow suckers, until late in his career. And I rang him up and said, what's wrong? What's going on, mate? Like, you were the biggest supporter. He said, you don't know what it's like, Steve. All grown mace, it's a sucker for rust. I just cover hounding, okay? And I felt sorry for him. But that's where we get an issue where you attack someone who's got the message that's right, but they feel they have to be silenced because it's just too hard, okay? Something's broken if we're there. Thank you.
Fantastic, Stephen.